Welcome to Module 3. For this module, we're going to concentrate on scientific writing. Writing from evidence, similar to the way we talked about in previous module, talked about writing about your personal story. Evidence is really the fundamental basis of all things that we tend to do in the STEM disciplines. So evidence-based scientific writing, as we started the entire course, is the basis for thinking about publishing, presenting, proposing, writing grants, to end up in a situation where you will have success, right? And the wheel on the left, which we'll talk about in greater detail later, goes through the entire publishing cycle in terms of what that looks like. We've talked, as I said a minute ago, we're going to talk about scientific publications, but this is part of the bigger picture of how does writing fit into your communication skill set. Creating a CV, a resume, particularly cover letters, which some of you might have written for the Module 1 exercise. We'll spend on the second half of the course, we'll talk more about speaking, but for now, the fundamental basis for even going on to the speaking part is learning how to create evidence-based writing for what you do. For the most part, when you talk about writing, you talk about two major or three major things that you end up having to write about. You either write a primary science article on the research that you may be doing in a laboratory. You might be writing a review article because the company that you work for wants to know more about a new direction they want to go in. On the other hand, part of the process that's really important for industry success is thinking about how you'd write a patent. So legalese, or writing for getting something to the point where it's intellectual property protected, is as important as learning how to write about reviewing and or publishing primary science. And a lot of things about primary science articles are very similar to what they would be as a review article. In fact, the introduction to a primary science article is very similar to the entire scientific review process. So why is it so critically important for you to learn how to do this and get really much better at it? Primarily because we need to inform the public of what is necessary to keep science going, so that we have clear communication that helps everybody know the value of the scientific work that you've done as a graduate student, the scientific work you're doing in industry, or the scientific work you're doing to further our understanding of the world around us. Transparency becomes critical because we actually need to create a bond of trust with the people that we communicate our science to. You can already think about how we've lost that degree of trust in other fields. We need to keep that trust in the scientific communication space. Scientists that engage in public communication really have a really strong reputation among peers. It's beneficial to your career. The better you can speak about what you do, the more people will want you to work in their environment, their academic setting, their industry setting. The more people understand that you are the person who can communicate what you do, the better it will be for your career. So cultivating connections with journalists might help make some of that possible. To some extent, you have to feel comfortable in making things understandable for the lay public. And so you see in the middle of this diagram on the right, which was published in 2015 in PNAS, lay abstract becomes an important component for thinking about what you need to learn how to do. And we'll talk about that in this section of the module as well. You can think about summaries from the perspective of how they can make something really, an image look really crazy. And you can think about how you really want to make sure that you accurately portray what you want to think about. So here's a movie summary that if you were to not provide an accurate indication of what you want, you could think of this as a Rudolph the Red-Nosed Reindeer experience with Santa Claus, as bullied kid with birth defect proves people are only nice to you when they need something. That's not the interpretation you want from this image. It's not sometimes the interpretation you want for your work as it is, that somebody takes it and misrepresents it. The one thing that you find out the more papers you publish, and I know anybody who hasn't experienced this, you get to find out that people misquote you in an article that they write. So in order for you to make sure that you minimize that, you have to be clear so that people take away the right message. So summaries, guidelines, you can find in lots of different places. I'm using this example from the National Institutes of Health. You could think of it from the Department of Defense, Department of Energy, the National Science Foundation. There are lots of places you can get these kinds of examples from. The National Institutes of Health requires fewer than 30 lines in a summary. They want plain language that can be understood by lay audience. What they mean by that is understood by Congress, which means maybe even sometimes less understanding than lay audience. No proprietary confidential information. You're not trying to give away secrets in this potential summary. The NIH summaries for funded grants are actually published online and available to anybody who wants to search them. They should include a brief background, the aims, objectives, or ideas that you want to feature in your proposal. Right? These are grant summaries, not necessarily article summaries, but they have to be able to tell people what's the significance of what you're doing to the relevant public, and particularly to the people who decide that your science is actually worth funding. So use it for all the purposes and think of it for all the purposes that it's important for. Right? So I said there's a similarity between primary science articles and science review articles. They're both peer reviewed. Patents are more than amply peer reviewed in order to be approved. They're all based on evidence. We will concentrate in this module for thinking about a primary science article, hopefully getting down to how you would report data or how you would report an introduction to what your idea is. There's a video that I suggest you watch. It's actually on the Canvas page for this module. It is a video by George Whitesides, who by the time he originally created this video in YouTube in 2011, he already had 1,100 publications. He is a prolific person. He's both working in the engineering space, the chemical space, and works prolifically in helping people in the third world by designing devices that cost pennies on the dollar. So a great person to emulate, and his advice is going to be incredibly useful to you if you can take his advice. Right? So he starts by thinking that you can write from the first time you start your project. So write at the beginning, write while you're doing it, and write to the very end. So, and that's a piece of advice that I would give you today as well. The two top things determining whether or not people will read your science paper really are the two top things that we don't spend a lot of time putting together. It's usually the last two things that you actually think about, and that's the title and the abstract. Right? They come about at the very end. When I started my career, I actually started writing titles to files so that I knew where I was going to put the data and under what title it actually fit. And that turned out to be a useful habit for me. That started over 160 papers ago, so it hasn't been a bad piece of advice from myself. I recommend it for others as well. Just think about what's the purpose that you're trying to go about as you create a title for it. Writing the abstract is going to require that you actually finish the work. If you think about titles that don't make any sense, this page, this image will give you a bunch. You can pause it here and take a look. These are not titles that you want to ever see put on your paper. One important thing that's useful for you as a scientist is that in the newspaper business, the editor actually chooses the title. In the science business, you get to choose the title. So just be careful about what you choose. Probably one of the most important overlooked facts when you try to start a project and think about what the paper is going to look like in the long run is people don't often pay as much attention to who the authors are going to be. And this is really a potentially big problem. In a class that I actually did in the 90s, I accidentally said something about authorship that had the students' principal investigator come back and yell at me because it actually caused the student to ask questions about other people that were included as authors. And that's the problem that arises, is that you start on a project, it's you and your advisor, and it ends up being you, your advisor, and maybe some technical help, you, your advisor, and a collaborator, you, your advisor, and another collaborator. By the time you get to the end of the work, you also have to think about, where are the authors going to list in the article? And the author order really determines a lot about who gets to remember you as an author of a maybe critically important paper. The first author is always cited first, right? So it's Smith et al., Jones et al. The last author, senior author, not so much as important as the name that's first. And you as a student or as an early stage investigator really want the credit for work that you actually started, did the bulk of, and are actually writing the first draft of the paper. And in fact, my rule for my laboratory is if you did the work and you write the first draft, that would make you the author of the paper. But every lab is different, and the most important advice I can give you is make sure that's a conversation you have with the principal investigator you're working with. Make sure it's really clear that it's going to be the number of people on the paper and how big it's going to get and how many collaborators you include. It's not something that's easy to add later. It's way better as a conversation at the beginning of the process. Abstract is sometimes all that anybody reads. So you really want to be brief and complete. You want to get all the significant points into it. It's got to be appropriate for the audience. It can't really be filled with jargon because there might be people that are new to the field that want to determine if your article is what they need, right? And then there's really big problems in the lengths of these things. In the old days, you could actually put over 500 words into an abstract. When the internet evolved, the internet put an end to that because they would truncate at 400 words. Some journals limit you to 250 words and other journals will limit you to 100 words. So you need to think about how you can really put all that information that's in this slide, right? Purpose, methods, results, conclusions. You need to be able to figure out how do you fit that into a space-limited domain. Some journals, and one we just got a paper submitted this recently, required that the abstract actually be broken up into 4 sections. So you really have to pay attention to the journal you want to submit to figure out the format that you want to create. It's not always easy to do this in just a few words, and wordsmithing is an incredibly talent dependent event. So start bigger than necessary, prune it down. It's easier to take words out than it is to try and think of adding more words because you don't have space for them. So just practice writing abstracts is important. One way to shorten things is an old famous quote, and one that I particularly love, about substituting damn every time you're inclined to write very. The word very is just simply unnecessary. So leave it out, right? When you think about summaries and abstracts, the world has been changing over the last 15 years. And so here's one example of a journal that's asking you not only to write an abstract, but write a second paragraph that is all about the importance of what it is that's in your paper, right? It's trying to get at 2 different audiences, one that might think about the newsworthiness, the other that might be more important just for the educated reader in the field. You can think of that secondary paragraph as a lay summary, and in fact, it's really a helpful exercise to be able to write lay summaries. Here in this particular journal, Journal of Bone and Mineral Research, they actually have regular abstracts, but they also require lay summaries. So think about how you would go about turning the language of a technical space in a fully technical abstract, so make it so that it's more readable to the general public and potentially the people that fund it for you, right? So write simple, short sentences. Jargon is evil. You've heard me say that in previous modules. Jargon is the one thing that you should come out of this experience doing less of, right? Use positive phrasing. Don't think about double negatives. Don't beat around the bush. Be straight and to the point. Don't use ambiguous words if you can avoid them. Use active voice as much as possible. That's a habit that scientists are really bad at. It's more than 50% of all scientific writing is probably in passive voice. So don't use big words. You want it to be simple and understood by your audience, right? And then answer the questions on the left, like why is it needed? What kind of study was it? What happened during the study? What are the results? Why do they matter? And why do they matter is the one message you need to get across. Remember the image of Santa Claus and Rudolph the Red-Nosed Reindeer. You want to make sure that you get across the right results that matter, not what somebody else interprets, right? And don't wait till the last minute to write it. You can get help from other people. This is the one piece that's read all the time on the internet, because if you pull up in any search process, the one thing they pull up is the abstract. That's when people decide if they're going to read your paper. So the one other thing that I'd add about writing an abstract is many journals right now, in fact, 2 of the last papers that we got papers accepted in, required graphical abstracts. such as the schematic diagram that is shown on this slide. So if you're not an artist, think about how you might find a friend that is good at artwork. Think about the figures that are in the paper and how you might adapt them to become part of your graphical abstract. There's many, many journals and probably many more to come that will be asking you for being able to add a graphical abstract on top of your abstract. So you get to the introduction. Now you're into the meat of the paper. You're actually reviewing papers in the field to see what's important and why you needed to do your study and why somebody should actually read your entire paper, because there are important key questions that you're actually going to do. This is not a data dump to say, here's all the papers I read to do this. It's just the key papers. And in fact, your reputation depends on you naming key papers and your reader believing you, that you actually named and put down the ones that are really most important. You should start at a high level, like why are you doing it to begin with? And then think about going to why you chose the reagents. By the time you get down to the last paragraph of the introduction, they should understand why you chose the approach that you chose to do the paper. At that 100-foot level, at that last paragraph, some journals will allow you to give a minimum portrait of what the results are going to be. You ultimately want to make sure that a non-expert can understand the rationale for the work. Remember, lots of people are starting in your field, and if they go to your paper first, you'd like them to think that, they will understand what they're going to do based on what you're doing. So you can go to a really specialized journal. For the most part, if you want people to read it, you're going to want to go to a less specialized journal. You'll get a larger readership. And in general, since everybody searches online, either Google Scholar, PubMed, and other search databases, they can find it if you put in the right keywords. So, but they'll read it best if it's approachable. And the highest yielding section for most novice readers is really going to be your introduction. So hook them at the top and give them the rationale that they can get to at the bottom of the funnel. You get to your materials and methods, and you can actually start writing this again at the very beginning while you're sitting down to do the experiments. You can actually put down all the details that are important for doing those experiments. Right? It's got to be brief, sufficiently complete to permit a qualified reader to repeat. There is rules that say you can say briefly similar to a previous paper that you did. You can say it brief and very similar to somebody else's paper, but ultimately somebody who reads your paper needs to be able to find out how to do it. If they have to trace down some other papers, it's okay. Don't make them trace down 10 other papers. So make sure that it's described in sufficient detail. And if it's a new procedure, make sure it's really explained pretty well. I still regret papers that I published where I haven't put down enough details, and I wanted to do and show it to other people, new people in the lab, and it actually had added more detail. So just be complete. Note modifications that are important. And where the word on the slide says where necessary, it's necessary if it's an important component of the procedure. Right? If you're studying new compounds, then make sure the compound structures are provided. And more important, on the grant side as well as in the manuscript side, authentication and validation of materials is required more and more. For National Institutes of Health, it's actually a requirement on every grant proposal. When you get to the results, right, now you've got, again, more formulaic ways to think about this. And some journals will actually make you combine results and discussion. But to some extent, if in a straight results section, you want to make sure that you've actually summarized the main findings in text before they actually get down to the nitty-gritty of looking at your graphs and tables, and especially before you get down to the nitty-gritty of saying something about the statistics. So every paragraph should start with a statement about the major finding that's in English, or at least the language that you're writing in. Right? You don't want to go straight into statistical statements because they don't have any context without you giving them a statement up front. You want to unfold the findings in a logical order to tell the story, not necessarily the order in which you collected the data. If you left out a group when you were doing the study and don't do it until the end, then you want to make sure that you tell the story in the order that it makes the most sense. It's the final result is not dependent on the order you did things. As long as you did the right controls at every point along the experiment, you're fine at reporting it in the order that makes more sense. Use appropriate statistical methods. This is not a statistics class, but in fact, you should all know that n equal 2 is not actually a statistically valid result for anything. It's mostly an anecdote. So make sure that you have got appropriate statistical advice. Many journals now, including one that I'm an editor for, actually has a statistical consultant that they call in for papers to make comments about whether or not the statistics are appropriate. So save yourself some trouble. Make sure you reach out for that person first, or at least fully justify what statistics that you do. Follow journal guidelines as best as you can. If you have a question, you can contact the journal, but the journal guidelines are there for a reason. They actually want to make sure that you submit it in a way that they will take it. And I just had an article bounce back because there were the subtitles of the regions in the journal, like materials and methods, they actually wanted it to say methods. So follow their guidelines. Requirements in some journals on the statistical side, they get really bothered by whether or not you use standard deviation or standard error of the mean. I have my own preference. However, you need to know what the journal's preference is in order to get the paper to the right place. When you get to the discussion, you're now thinking about what's most important about your paper. You want to restate, not simply repeat, but what's the primary result you want somebody to walk away from? Sometimes instead of reading the intro as somebody who's been in the field for a while, I'll actually go to the first paragraph of the discussion and the last paragraph of the discussion. Everybody reads papers differently. Some people will just turn to the figures, but make sure that if somebody wants to get the bottom line message, they can get it from the first paragraph in the discussion. You want to put perspective into the field as you write this. So does it agree or disagree with other results that are in the field? It's not simply about you. It's about you relative to whatever other people have found. Are you finding a result that's different than somebody because they did it slightly differently? Are you finding a result because you added an extra twist that you think was particularly important? What's the reason for differences between your result and somebody else's? Make sure they understand your model. Scientists don't always think about marketing, but in fact, your ideas are things that you are selling to the people that read your paper. So market the model that you use to try and get other people to follow you. Discuss the shortcomings. In fact, some journals nowadays require that you have a paragraph in your discussion that simply says limitations. So think about where you might be short in what you've done and where you actually need to call for people to do another study or yourself to do another study. Think about whether or not there are implications that might be used in the future. And you can suggest future studies. Some people are afraid to do that. I tend to love telling people what's a great study to do that I will never be able to do because it will be too expensive or it takes a larger team of people, right? You don't have to tell them the study you're doing next. It might not be a bad idea to tell them a study that you've actually finished, but are submitting in another paper. It's again, your career is a series of papers, a series of discovery, and whether or not you're telling people as you're going or in front of when you're going is a way to think about it strategically so that you can basically market your next paper because you already know you finished it and you already know you want to get the reader of this paper to read the next one. Don't speculate out of turn. If you get too wild, that's not going to make a reviewer happy. But schematic diagrams, to the extent that they will put out a picture of your model, are really useful. I've had people actually take schematic diagrams out of papers and borrow them and put them in review papers. That's a particularly useful thing to do. It's really important if people start thinking that your papers are providing them with stuff that they can use in their own work. So don't forget to say thank you. Acknowledgements are important, particularly to the people that funded the work. So financial support is actually required. There is a point in time, probably still true, that citing that the work was funded by a not particularly well-liked industry might actually not work well in your favor. So at one point 20 years ago, and that's what I think is still true, it's not great if the work is funded by the tobacco industry, if the work is about how tobacco is not harmful, right? People are not going to be, they'll be skeptical about whether or not to trust it or not. So make sure you're upfront and honest, but make sure that you counter any potential ideas that might be biased that are within the work itself. Know where the conflict of interest might be, and that's why you actually have to state it in the paper. Additional acknowledgments, you need to put people in that are technical support, but without authorship level contribution. So remember earlier in this module, I talked about authorship is one of the most important conversations you'll have. That authorship level should be for only people that contribute in scholarly way to the work that was done, not simply doing something that you told them, but simply contributing to the scholarship that was in the paper. People have done honorary authorships in the past. It became a little bit problematic over the course of time because every once in a while, if a paper has a problem with it, an honorary author will get painted with the same brush as the people who may have actually done things wrong. So think carefully about who's an author and who's an acknowledgement. People that make other important contributions. It could be somebody who just reads the paper for you, that proofreads it to make sure that you didn't make any glaring errors or included something that you forgot. Right? Could be somebody that provided animals, reagents, gave feedback during the study or not. Right? So don't leave out the acknowledgments. At this point, the last section of the paper is going to be your references. And you need to make sure that you choose references that are, one, very legit, and two, that demonstrate that your scholarly knowledge of the field is real and broad, and that you know all of the important parts that need to be cited in the paper. There are some journals now that limit the number of references you can include. Brief reports or short reports frequently have limits of 20 references. They expect you to choose references that are reviews, not necessarily primary research articles. On the other hand, your ability to choose the most critical primary research paper in a field shows your scholarship. So demonstrate it wherever you can, wherever it can fit within the list of literature that you can cite. Citation formats are determined by the journal and they vary widely. So make sure that you know what format they have to be in. And it's also why that you need to think about what a reference manager will look like, which we'll talk about in a second, right? Use the reference manager of the lab you're in or of one that you think you will use for a really long time. There are lots of them. EndNote was very popular at one point. Mendeley is another one that is supported by some places. Use the one that you can get the most support on and the one that you can share with other people that you write with, particularly your PI, but other people in the lab. Here's another one that I didn't mention. Zotero is another one that's recommended by the CSU library in addition to Mendeley. They're free up to a certain number of references, and then there's a paid version that you might have to move to. So EndNote, like I said, it was very popular, and then they raised the price, and then it became a little less popular. You need to still proof your references to make sure that it didn't make mistakes. The first time we did a paper in EndNote a dozen years ago, EndNote actually mixed them all up. And so we had to go back and do them all by hand. It doesn't do that as much now. There's still errors that we've seen pop up in EndNote, which is the one my lab uses the most. So whichever one you use, don't assume that it's going to do it correctly. So to wrap up, a general approach to writing a paper has you writing the materials and methods as you do the study so you don't forget something. Prepare and organize the figures. It's probably the most important part to what you're going to report because that's your data, right? Make sure that you figure out what are all the figures you need, and you can write the legends as you create the figures. Once you have all the figures, you can write the results. And then think about writing an outline that gives you all of the most critical paragraphs you're going to need in the introduction and discussion. I have had many students write an introduction and write an discussion, and the first thing I end up doing is saying, could you go back and write an outline of the intro and discussion? Because when you read it as a whole, you realize that the order in which they're putting the concepts don't fit. You can save yourself some time by actually writing the intro and discussion as an outline to start with. Write the title and the abstract. As I said in the beginning, I suggest you actually write the title as you start the study, and then write the abstract once you have the data intact and you know how to summarize it quickly, right? The title is something that you can modify depending on what the findings are, but at least the guiding title that you can start at the beginning will actually guide what kinds of things you're actually thinking of doing. And don't be afraid to show it to lots of people. You may be learning and improving your writing skills now, but again, 160-page papers into it, I'm still learning how to write better. It's not something that you can ever say, oh, now I'm done. I'm as good as I'm going to get. You can always get better. So keep on showing things to people and revise whenever you can. Put finishing touches on a manuscript before you send it out the door. Nowadays, you have one extra consideration, and that is this issue of plagiarism on the one side, and that's linked hard in every way to what ChatGPT and large language models can provide. They are automatically plagiarism machines because they're based on taking information that's out on the internet and then creating text from it. There's almost 99% probability that there will be plagiarism in a ChatGPT piece of text because it's getting it off the internet, which means it's already out there. So a lot of places will have plagiarism detectors. One colleague of mine had to write summaries or papers for scientific meetings that he would go to. And he went to 2 meetings in 1 year, and he submitted papers that were very comparable to the 2 meetings, which were published in 2 different journals. One of those journals ended up retracting the paper because they considered it plagiarism. That was plagiarism of himself, not plagiarism of somebody else. So this issue of plagiarism is not minor, and it could cost you time, effort, and respect in the field that you want to work in. So just be careful about where you do that. And actually, don't be careful about it, just don't do it. The peer review process for journals can be a little bit unwieldy. You do the study, you write the results, you send it to a journal, and you hope that they give you feedback soon. As an editor for a journal, you send it out to reviewers and try and get people to agree to review it, usually with the idea that they turn it back within 1 to 3 weeks. Some people don't turn it back for months. I had somebody wait 2.5 months before he gave me back his review of a paper, and I had to pester him every 2 weeks to get the journal review back. So it's not as simple a process as you want it to be. At the same time, some journals take forever to get you feedback. We actually submitted a paper, we waited 9 months, I think, and then we finally pulled the paper from the journal and sent it somewhere else because they just were not doing it at a speed that we thought was fair. So they will give you your feedback, hopefully in a reasonable amount of time. They will ask for revisions. In my entire lifetime, I've only had 1 paper accepted without revision, and I was a graduate student at the time. It was a time when there weren't any word processors. So maybe people felt a little sorry that you had to type it the entire way. But you're going to end up having to do revisions. So just expect that when you submit the paper. Get it back to the journal as fast as you can. Hopefully they don't ask for new experiments and only ask for changes in text, but no guarantees. A lot of journals at the higher end always ask for new experiments, and that actually takes time. Some journals will give you a limit on how long before you can resubmit. Pay attention to whether or not the journal is actually asking you for a limited amount of time before you do it. And then once you satisfy the journal, I've seen as many as up to 2 to 3 revision cycles, but hopefully it ends up in print and everybody who needs to read it will read it because you did the title right, you got the abstract right, and they will see it on a database server someplace and be able to cite you. There are lots of resources that CSU provides. There are resources that other places provide. Use resources. Don't assume that the fact that you're in the middle of a degree program means you're on your own. You're not on your own. You're taking this class. You have help from Megan Hollis. You have help from a bunch of people that are here so that we can actually get you to be better for every journal article or everything you want to submit. So I'll leave you to the practice. Enjoy putting things together. We'll take a look at it in a little bit and give you some feedback and see if we can repeat the process so that you can keep on getting better at what you do. Thanks for listening, and we'll see you along.